Hello students, in previous lecture we have seen examples on cycle transpositions. Next we will see in this lecture examples. Find the maximum possible order possible order for an element possible order for an element of Sn for given value of n for given value of n. So find out the possible order for an element Sn for value of n. So first n is equal to 5 means what? To find out maximum order in S5. So here we have given first n is equal to 5. Next second one n is equal to 6. Third one n is equal to 7. And fourth one n is equal to 10. To find out maximum possible order in S5, S6, S7 and S10. So let us find out. So let's see the solution. Means to find out maximum order in Sn for n belongs to, so n is equal to 5, n is equal to 6, n is equal to 7, n is equal to 10. Now here first one, now to find maximum order of an element in first value of n is 5 in S5. So to find out partitions of 5, so let us find out. Now here n is equal to 5, so here I will write here n is equal to 5. So let us find out, to find possible partitions of 5 which gives maximum LCM, maximum LCM. So I will write 5. So 5 is the first partition. Now means the number whose sum is 5. So 5 is first partition. Now 5 can be written as 2 plus 3. Next, so here 2 plus 3. Next I will write it as 1 plus 3. Next partition I will write it as 1 plus 2. Next I will write 1 plus 1 plus 1 plus 1 plus 1. So this is again partition. Next, so here 1, 2, 3, 4 and 5. Next I will write 2 plus 1 is another partition. Next here 5, 2 plus 3, 1 plus 1 plus 3, 1 plus 1 plus 1 plus 2. Next 1, 1, 1, 1. Next 2 plus 1 and next 1 plus 4. Next 1 plus, here 1, 2, 3, 4, 5, 6, 7. So these are all the partition. Now in this case, so to find partition of S5 which gives maximum LCM. So among this partition, which partition gives most or maximum LCM? So here 5 which gives only itself, so it is 5. So next I will write here 2 and 3. So what is the LCM of 2 and 3, which is 6. Now here 1, 1, 3. So 2, 3 means what? Which is 2 cycle of first is of length 2 and second is of length 3. So this is 1 plus 3 means what? This gives 3 disjoint cycle. So which has 2 cycle which has only one element and one cycle which has 3 elements. Next 1 plus 1 plus 1 plus 2 means what? It has 3 elements of means 3 cycle of 1 element and 1 cycle having 2 elements, and last is 1 plus 1 plus 1 plus 1. So it has 5 cycles of 1 elements, and here 2 plus 1 means what? So 2 cycles having 2 elements and 1 cycle having 1 element, and 1 plus 4 means what? So 1 cycle having 4 element and 1 cycle having 1 element. So here, so we have to find out permutation in S5. So here total set A has 5 elements, means 1, 2, 3, 4, 5. So among that, what is the maximum possible order? So here suppose I have these 5 elements. So suppose 5, so 2 plus 3, so means suppose I have sigma which has permutation 2, means 1 goes to 2, so means first cycle having 2 elements and second cycle having 3 elements. So here 1 2, next 3 goes to 4, 4 goes to 5. So LCM of these two, so order of sigma is LCM of, so order of this is 2 and order of this is 6, or sorry, here 3. So LCM of these two is 3 into 2, 6, right? So here if I take this 2 plus 3, then I get LCM 6. If I take 1 1 3, then what will be the LCM? So for that I will get order of sigma is equal to LCM of, so order of means, for that I will write in the cycle form, I will write it as sigma. So here this is sigma 1 and this is sigma 2. So this is single cycle, means 2 cycle having length 1. So I will write it as, so here 1, here suppose I will write 3, and next cycle having length 3. So I will write it as here 1, next 2 goes to 4, 4 goes to 5, right? So like this. So here LCM of this will be LCM of, so it has this is single 2 cycle having length 1. So LCM of 1 1 and 3, which is again sorry, here which is 3, means among these, so what is the maximum LCM? So here 5, here we will get LCM 3 into 2 6, here we will get 3, here we will get 2, here we will get LCM 1, here we will get LCM 2, here we will get LCM 4. So among that we get, if I take these 2 cycles, here I get only 2 3 is the maximum order, because this 5 means what? Only single cycle, which is suppose 1 2 3 4 5. So this is a single cycle which has having total 5 element, and 2 plus 3 means what? It has first cycle having 2 elements and second cycle having 3 elements. 1 goes to 2, 3, here 3 goes to 4, 4 goes to 5. So this is first cycle, this is second cycle, which is partition of 2 plus 3. Now 1 plus 3 means 1 plus 1 plus 3 means what? It has 2 cycles having 1 element and 1 cycle having 3 elements. So example for like this 1 3. So it has 2 cycles having single element and 1 cycle having 3 elements. So LCM of this will be 3. Here 5 has LCM only 5, and here 5 can be written as 2 plus 3, which it has LCM 6. Means among this, what is the largest LCM? We will get 6. So among that partitions, if we take, so among that partition, which partition gives maximum LCM? So here 5 gives only 5 LCM 5, at 2 and 3. So this is partition of 5, which is 2 and 3, again which gives LCM 6. Next 1 plus 1 plus 3, which gives LCM 3. Again 1 plus 1 plus 1, which gives, so LCM of these two numbers will be 2. Here 1 plus 1 plus 1 plus 1, which gives LCM 1, which gives LCM 4, and this gives LCM 2. So among that partition, if I take, if 5 can be, if I take, or if we take cycles, if we take disjoint cycles of length 2 and 3, take disjoint cycles of length 2 and 3, that is 5 is 2 plus 3, then order of that element, and then LCM of 2 and 3, which is 6. Therefore 6 is the maximum order of element in S5. Therefore 6 is maximum order of element in S5, right? So maximum order of element in S5 will be 6. Now let's see next element 6. So here to find, so second example, to find maximum order of element in S6. Now to here n is equal to 6. Now to find possible partition of 6 which gives the maximum LCM. So here possible orders will be, so I will write 6. So possible orders, so 6 can be written as like this: 6, next 1 plus 5, next here I will increase first number and decrease second number, 1 plus 5, next 2 plus 4, next 3 plus 3, next this can be again write 1 plus 4, this can be write 2 plus 1 plus 3. So I put first element as it is and partition of second. So here 1 as it is, 5 has partition 1 plus 4. Here again I will put 2 plus 4, which can be written as 2 plus 1 plus 3. Next 3 as it is, addition of this 1 plus 2. So 2 plus 1 plus 3 and 3 plus 1 plus 2 has same element. So I will write only this. Next 1 plus 1, so 1 plus 1 plus, so I will write it as 1 plus 3. Next 1 plus 1 plus 1 plus 1 plus 2. Right, last 1 plus 1 plus 1 plus 1 plus 1 plus 1. Next this can be written as 2 plus 1 plus 1 plus 2. So here this is again another partition. Next, so these are all partition. Among this partition, which partition gives maximum LCM? So here if I take 6, only one cycle of length 6 which gives order 6. If I take 2 cycles, first cycle having only one element and second cycle having 5 elements, so LCM of these two will be 5. If I take 2 cycles, first cycle having 2 elements and second cycle having 4 elements, so LCM of these two, 2 and 4 has LCM 4 again. Now next, if I take 2 cycles having 3 elements, means which both are disjoint, then the LCM of these 2 cycles will be again 3. Next, if I take 1 1 4, then LCM of these 3 cycles will be again 4. Next, if I take 2 1 3, then LCM of this number will be again 6. Next, here if I take LCM of 1 1 1 3, which is 3, and here I take LCM of 2 1 1 2, then I will get LCM 2. So maximum LCM among that partitions, if I take sigma is, or I take 6 is equal to 6, or I will write 6 is single. If we take one cycle of 6 element, or 2 cycles or 3 cycles having 2 1 3 elements. Therefore LCM of 2 1 3, which is, so LCM of 2 1 3, which is 6, and LCM of, here I will take single cycle which has total 6 elements. Therefore maximum maximum possible order order in S6 is 6, because I will take single cycles having 6 elements or 3 cycles, which first cycle having 2 elements, second cycle having 1 element, and third cycle having 3 elements. That is, I take sigma, which is 6 cycles. So 1, 2, 3, 4, 5, 6. Right? So these are 6 elements, or I will write this is sigma 1, this is sigma 2, which is I will take 1 goes to 2, or 3 goes to 4, 4 goes to 5, and I will put 6 goes to 6 as it is single. So this is the possible order, means here possible order will be 6 in S6, which is the maximum one. Now third, for n is equal to 7. So to find maximum order of an element in S7, now here n is equal to 7, to find possible partition of 7 which gives maximum LCM. So let us write. So find out the partition which gives maximum LCM. So here 7, so I will write 1 plus 6, next 2 plus 5, 3 plus 4. So these are partition. Next I will put first element as it is and partition of second. So here 1 plus 1 plus 1 plus 5, next 1 plus 1 plus 1 plus 4, and like this. So here again, here I will put 2 as it is, partition of second element 1 plus 4, next 2 plus 1 plus 4 can be distributed 1 plus 3. So again 2 plus 1 plus 1 plus 1 plus 2, like this. So here 3 plus 4 can be distributed 3 plus 1. So again 3 plus 1 plus, here 3 can be distributed, here plus 2 plus 1 plus 1, like this. So this is repeated, so I will cancel this. So these are some partitions. So among that partitions, so these are all partitions of 7. Among that partitions, so which partition gives maximum LCM? So here 7 will give only one cycle of length 7 and 1 6. So whose LCM is 6. Here if I take 2 and 5, whose LCM is 10. So 7, if we take single cycle of length 7, then we get order 7 only. We will get order 7. Now if we take 1 6, if we take cycle of length 1 and 6, then what is the LCM? So LCM of 1 6 will be 6. Now if I take 2 5, if we take cycle of length 2 and 5, 2 5, then LCM of 2 and 5, which is 10. And if I take 3 4, if we take cycle of length 3 4, then LCM of 3 and 4, so LCM of 3 and 4 will be 12. So here if I take single cycle, means in S7 I will take single cycle. Suppose 2 goes to 3, 3 goes to 4, 4 goes to 1, 1 goes to 5, 5 goes to 6, 6 goes to 7, which is single cycle of total how many elements? 7 elements. So which gives order 7. If I take 1 and 6, so two cycles having 1 and 6 length, so I will write it as, so here 3 4, so total there are 6 elements, and first 6 is a separate, so here one cycle having only one element. So here this is 6 cycle and this is this cycle having 6 element and this cycle having 1 element. So LCM of these two will be 6. Now for that order 10 we will take one cycle having 2 length and second cycle having length is 5. So here I will write 1 2 next 3 4 5 6 7. So LCM will be 10. So if I take two cycles whose length is 3 and 4 simultaneously, then here I will take 1 2 3 and second one is 4 5 6 7. Then in that case we will get maximum order which is 12. Therefore maximum order in SN7 is, therefore maximum order in S7 is 12. Now next find out maximum order in 10. So last one in S10. So here n is equal to 10 to find possible partition of 10 which gives maximum LCM. So I will write 10. Now 10 can be written as 1 plus 9. So LCM will be 9. Here I will write 2 plus 8. So LCM will be 8. Now I will write 3 plus 7. So LCM will be 7 into 3 21. Now if I write it as 3 plus here I will write 4 and I will write this 4 and 6. So LCM will be 12. So this is addition. So 4 plus 6. Next I will increase 5 plus 5. So if I take partition of two cycle which has 5 elements, so LCM will be again 5. Next I will write here this 3 plus 7 can be written as 3 plus 4. Here I can write it as 3 plus 7 can be written as 3 plus 2 plus 5. So which is 3 cycles having 3, 2 and 5 element. Then what is the LCM of these two? 3 into 5 has LCM 6 and 6 into 5 has LCM 30. Means maximum order in S10 will be 30. So if I take LCM of 3 to 5 which gives maximum LCM. Therefore if we take 3 cycles of length 2 3 5 we get maximum LCM. Therefore maximum order in S10 is equal to LCM of 2 3 5 because addition of these three numbers will be 10 and LCM of these will be 30. That is maximum order in S10 will be 30. That is I will take element sigma will be like this. So first cycle having two elements. So I will write suppose 3 and 1. Second cycle having 3 elements. So here 1 3. So 2 goes to here 1 3 2 goes to 4 goes to 5. So this is first cycle having 2 elements, second cycle having 3 elements and last cycle having 5 elements 2 4 5 6 7 8 9 and 10. So 3 plus 2 7 5 elements. So this is a cycle which belongs to S10 having maximum order. So whose order is 30, right? So these are the maximum order in particular SN group. Next example, if beta is equal to 1 2 3 1 4 5 which belongs to S5, express or find beta inverse as product of disjoint cycle, as product of disjoint cycles. So here what is beta? Beta is the product of two cycles which is not disjoint because one is the common element between these two cycles, so which is not disjoint cycle. Now let us find out beta which is the permutation. and to find out beta inverse. So we know that beta is the permutation, and the definition of permutation, which is the 1 1 and onto mapping from n natural numbers, right? So which is 1 1 and onto means what? Beta inverse will be exist. So let us find out this. So first find out product of these two cycles. So here we know that which total we have total 5 symbols. So here beta can be written as 1 2 3 4 5 because we have 5 symbol. Again 1 2 3 4 5. So here 1 goes to 2, 1 goes to 2, 2 goes to 3, 2 goes to 3, and 3 goes to 1, 4 and 5 as it is. Now in this cycle 1 goes to 4, 4 goes to 5, and 5 goes to 1. So 2 and 3 as it is. Now let's take product. Again we have total 5 elements, 1 2 3 4 5. So 1 goes to 4, 4 goes to 4. Next 2 goes to 2, 2 goes to 3. Now for 3, 3 goes to 3, 3 goes to 1. For 4, 4 goes to 5, 5 goes to 5. Now for 5, 5 goes to 1, 1 goes to 2. So this is beta. Now to find out beta inverse, therefore then beta inverse, to find beta inverse. So to find out beta inverse means what? So if I have so this element is like this, beta of A is equal to B, means image of A is B. So beta inverse, if I take beta inverse, then what will we get? Beta inverse of B is equal to A, means inverse image of B is A, means inverse the image of this element will be A. So this element. So here beta inverse. So I will write here 1 2 3 4 5. Then here image of 3 is, so here by using this definition beta inverse of B is A, means here B will be like this element and A is this element. So here in image of 1, so image of 1 is 3, next image of 2 is 5, next for 3 image of 3 is 2, next for 4, 4 is 1, and element of 5 has image 4. So this is the beta inverse. Now it can be expressed as product of disjoint cycle. So write down it as product of cycle. So here 1 goes to 3, 1 goes to 3, 3 goes to 2, 1 goes to 3, 3 goes to 2, 2 goes to 5, sorry here 2 goes to 5 and 5 goes to 4 and 4 goes to 1. So 1 is in our set. So this is single disjoint cycle. So this is beta inverse, right? So this is the inverse of permutation. Now we will stop here. Now in next lecture we will see cosets and Lagrange's theorem. Thank you.